you want to start with? Which?
Negative x squared times x minus 2 cubed times x plus 5.
Good. So what is the degree of this polynomial?
6.
Very good. Maximum number of possible terms. It doesn't have to be that, but what is the maximum possible? Good. What is the domain of this function?
Negative infinity to infinity.
Right, it's a polynomial function. So I'm expecting 6 solutions.
Zero twice.
Correct. Which means multiplicity 2. Good.
Positive 2.
Yes, multiplicity 3.
Negative 5.
So x equals negative 5, multiplicity 1. And 3 plus 2 plus 1 is indeed degree 6. So negative 5, 0, and 2. All zeros, of course. What do I write for 0?
100.
Very good. What do I write for negative 5? Cross. What do I write for 2? Very good. But not the same type, so I'm going to say flat.
So we say long. I said long.
Fine too. Whatever works. I agree. Good. And behavior.
It's going down.
Exactly. Because the degree is even. And I expect this or this. Yes.
So just a question about how we answer it. If we show this table
That's
like that,
that's all I need.
so we don't have to make a list.
But you also have to add the symmetry. Right? So not symmetric. Because f of negative x will never equal f of x for sure. And it will not equal negative f of x. So the function is not even and it's not odd. Good. So now here's my graph. Did you graph it without looking at the graphing calculator?
First.
Awesome. Because that's the only way to learn. Good. So here is my take on it. So at negative 5, at 0, and at 2. My chart says from negative infinity cross normally. It has to have a turn because it has to come to a minimum and turn again to 0, 0. It has to come to a maximum again and then cross flat or slowly, whatever you want to call it. This is definitely the graph. No one can find anything else. So now in y equals, I have to put in the function negative x squared and in parentheses x minus 2 cubed. Oh, I always do that. X minus 2 cubed. And then x plus 5. Do we all have some? I'm checking. Negative x squared, yes. X minus 2 cubed, and x plus 5. Do we all have this in the graphing calculator? Yes? I already know that I shouldn't be going too far below the x-axis because there is no action below the x-axis. I don't want to waste my time. So when I go to the viewing window, I will start at negative 1. Since you already checked this, I guess for me, I don't know how high this should go. I'm going to put 200. Well, I already see it. It's right here. So, okay, so for x, you cannot be more than 3, 5 at the most. So I made a mistake. I was thinking in terms of y. Sorry about that. So negative 7 to positive, let's say 4. And y minimum, negative 1. And y maximum, and now I see it, it's going way up. Okay, I'm going to say 500 with a scale of 100. And see what happens. I can't see it. Okay, fine. So I go back to the viewing window. It's up here, not too far. I go back to the window, and I change this into 1500. And graph again. Okay, it's not good enough. Okay, go back to the window. That's what you have to do. And I go to,
4,000.
okay, maybe 5. With a scale of 1,000. Okay, and that's how I determine it. Trial and error, I don't know. By looking at the function, I can figure it out whether the maximum will be this or maximum will be that. Is this better? Yep, that's all you need to do.
So you can't figure out the max?
Yes, of course, now you have it.
Oh.
Now you have it, you go from left to right. Put a left bound. So I know that the maximum is somewhere between -5 and 0. So you put the left bound to be -5 and the right bound to be 0, and it will give you, once it shows in the graph, it will give you the maximum. But it has to show. So if the graph doesn't show, the calculator may not give you the max. So how will you do that? So you will go to second and calc, and you choose maximum. And you choose the left bound to be -5 and the right bound to be 0, because we already know the graph. Is this okay now?
Like, how do you get the actual number? Don't you have to have the actual number? Or you just want to,
No, so I stopped because I thought it was clear. So I have to choose 4. You choose the left bound as being -5, the right bound as being 0, and enter, and it will give you the maximum. Unless I plugged in, so -5, enter, 0, enter, no guess, and it will give you the maximum. So you told the calculator to look for a maximum between -5 and 0, and it gave you the maximum. The maximum is 3, 4, 5, 6. When x is -4. Is that okay? But you have to use this calculator to find the maximum. Did you find yours? Oh, you did. That's why I offered. That's okay. Okay. Is this better? Is this clear now? And in the same way, you have to find the other maximum between 0 and 2. We have a maximum here and a maximum here. So you have to find both. Is that okay? Any questions now? Anything else? Did you try anything else? Did you work on anything else that you need help with? Anything? Susan, is this okay now?
yes, thank you.
Anytime. Shelby, are you okay? Did you get it? Yes? So you got all the steps. It's -x squared. Oh, you have a different function. Okay. Okay, anything else from me?
We'll go over synthetic division again.
Yes. So please give me any, or I can find, or you can find.
Can we do word problem?
Yes, of course. That's why I'm here. That's why I'm asking. I'm begging for questions. Yes, please. I'm begging for questions. So we're looking for a synthetic division on page 392. Please choose. And then a word problem. Yes. Yes?
21.
21. 21 on page 392. 21. Very good. So we have 4x cubed minus 3x squared plus 3x minus 1 divided by x minus 1. Here's the question. Can I use synthetic division for this problem? Yes, we agree? because the denominator is 1x power 1, and then minus or plus a number. Yes? Okay, perfect. So the algorithm says that in the box, I have that little a. So what goes in the box? 1, just 1. So the denominator has to be x minus a, and then I identify a. If this is positive, when I identify a, it's negative 1. So if I have x plus 5, I put negative 5 here. If I have x minus 3, I put 3. I have to identify what a is. And this is x minus a. Is that okay, everyone? Yes? Okay, 1. So now I look at the numerator. It's in descending order. True? Degree. When I divide degree 3 by degree, what degree do I have to get as the answer? So remember that. The final quotient, the degree of the quotient, has to be 2. Okay, so please dictate the coefficients. Yes? 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 Good. Right under negative 1, I will have to box it in because this will be, if it exists, this will be the remainder. Good. First step. Yes, I copy 4. Awesome. 1 times 4. I write it right under negative 3. I perform the operations I see. Tim, are you with me? Is this okay so far? Okay, so 4 minus 3. Good. 1 times 1. Perform the operations you see. Perform the operations you see. 4. 1 times 4. Perform the operations you see. That's it. So now I have to write the answer. And remember, I can always check the answer. I don't need anyone to tell me whether I made a mistake or not. So the answer would be, yes, 4x squared. Good. I need a symbol. Without a symbol, I will not have the correct answer. Very good. That's it. Is this okay? Yes? Any questions? Any questions? We have 2 more sections that I'm hoping to accomplish today. And then on Wednesday, I would like to review all this again for test 2. Okay? So let's work on these. See if we can accomplish them tonight. And
can we do word problems?
oh, yes, of course. I'm sorry. Yes. Yes, of course. Yes. Which word problem are we looking at?
I don't have any. There was some of them I'm not.
Can you bring them on Wednesday? Take either a picture with your phone or email them to me or something, so because I don't know what you saw and I like to solve the problems that you looked at. Is that okay? It's gonna be a perfect review for this. Okay, the next section is 3.5. Rational functions. Did I start this or not? Yes, I did. Oh, I'm happy. Rational functions. I consider this topic possibly the most difficult one. I wouldn't say, I will take it back. Not difficult, but a lot of steps. Cumbersome. We have to think in totally different terms than before with any other function, like linear, quadratic, polynomial functions. This is totally different. Totally different. It has a lot of different things in it. So, of course, we're asked to graph them. And can anyone give us a rational function. And then I will give you examples. Okay, so we don't know what a rational function is, which is fine. We have not really graphed these functions. It's a polynomial divided by another polynomial. So a rational function is nothing else but a ratio of two polynomials. Bless you. Ratio of two polynomials. We will look at three different situations. Only three different situations. And I am going to call them, the book does not call them that way, but it's easier. You can call them, we can change their names, but I need to call them somehow. So there are three different types. I'm going to call them type 1, type 2, and type 3.
Also give us what the book calls them by.
Doesn't. No name. But I have to differentiate them. Because when I'm going to look at a function, I'm going to ask you what type is it. So you have to be able to identify instead of talking for 5 minutes about what type it is. I just want you to say type 1, type 2, type 3. And not have to say, oh, is that one that does this and does that and maybe this and you divide this by that. Okay? I'm going to give you a couple of examples of type 1. F of x, x plus 1 over x minus 2. Another function, f of x, x squared minus 1 over x squared minus 4. Then type 2. And then I'm coming back to them, and we'll talk about them in a minute. F of x, 1 over x minus 1. Another f of x, x plus 1 over x squared minus 9. Type 3. F of x equals x squared plus 1 over x. Another f of x, x squared minus 4 over x plus 1. I'm going to make it x plus 2. It doesn't matter. Really. Okay. Looking at these three different types, is there anything that you see that happens in type 1?
The degrees of they're the same for the first division.
That's all I needed you to say. In type 1, degree n divided by degree n. That's what it means. Same degree over same degree. Awesome. That's all it means, type 1. Type 2. When you look at type 2, what would you say? That what happens in, say it again. Nope.
Minus n minus
Um,
1 or plus 1.
Comes before.
I changed to 4.
The one on the bottom has the higher degree.
Excellent. Degree n and degree greater than n. It can be by 1, by 2, by 5, as long as it's greater. Awesome. That's what it is. Type 3. Now this is specific and I can change it. Or I can change it exactly. 1 less in the denominator. Absolutely. So this is degree n and this is degree n minus 1. Mandatory. Very good. So this is the difference among the three. These will not be as difficult as this one. This is more involving than these two. Once we understand number 1, number 2 will be trivial. Number 3 requires a little bit of work. Okay, so let's start with number 1. I'm going to start with that example. F of x equals x plus 1 over x minus 2. We're asked to graph. First, I'm going to ask myself, like we did before, what type of function is this? Is it linear? Is it quadratic? Is it a polynomial? Is it rational? Is it radical? Is it absolute value? What is it?
Rational.
It's a rational function, correct. So here's the list that I have to go through before I graph a rational function. 1. Domain. 2. X and Y intercepts. I'm going to put in parentheses and multiplicities for which of these two? Of course, there is no multiplicity for Y-intercept, for X-intercepts. Good. 3. So far, nothing new. Now it's coming. Vertical asymptotes. We have not seen this before. This is new. 4. Behavior near vertical asymptotes. Five. Horizontal or slant asymptote. 6 we've seen before, and behavior. 7 we've seen before, max or min. 8 we've seen before, symmetry. 'Now I have to say that the following can be grouped together, and we will. Not in the first example, but the second, the third. These two can be grouped in one step. These two can be grouped in one step, and you'll see how and why. Like before with polynomials, the first example will take 10 minutes, 15 maybe, because I have to explain each and every item. But the next example will take 3 minutes. The next one will take 1. And the fourth one will take 1, and so on and so forth. But the first one is long, because I have a lot of explanation. Okay. Of course, we are going to create the same type of chart. Of course, we're going to look at the chart only, and we are going to graph the function from the chart. Everything, the rest is the same. But just these two, actually 1, 2, 3, are not clear yet. They will. Okay, so I'm starting with this function, and then I'll let you pick another function of type 1. So f of x equals x plus 1 over x minus 2. Let's get the chart going. We put all the information there as we did before. Okay. First question is, perfect. What is the domain of this function?
Negative infinity to union.
Negative infinity to 2, union.
To infinity.
Why? Anyone else but Susan? Why do we exclude 2? Because at 2, what happens at 2?
Make it zero.
You can't divide by 0.
Which means the function is undefined at
2.
Very good. So negative infinity, remember 0 has to be in the chart no matter what, always, 2 and infinity. So We established the domain. I did not write it. But once again, what will I write under 2?
X or something?
Nothing. I cannot write anything under 2. The function is undefined. Say it again. Is this okay? Good. So we're done with that. The Y-intercept is easy. How do I find the Y-intercept for any function? Awesome. I plug in 0 for x. Look. I covered them because they disappear. So when x is 0, y is? That's it. Awesome. Okay, so this is also done. Now the x-intercepts. When is a fraction 0? Right. When is x plus 1 0? When x is? Done. The first two are done. What about multiplicities? What will the function do at -1? Say it again. Yes. No. Multiplicity 1. X equals -1 once. Cross. Straight cross. Right? Multiplicity 1. Straight cross. The easiest possible. Very good. Now we reached this. When a function, like this one, rational, is undefined at a value of x, so at x equals 2, the function cannot go this way, cannot cross x equals 2, correct? Because it's undefined. Or it cannot go the other way, this way, right? It cannot do this and it cannot do this when x equals 2. What happens here is, because the function is undefined at 2, the function will do this. Or it will do this. I don't know which one or the other. On the other side, it will do this, going to positive infinity. Or it will do this to negative infinity. I haven't checked which one. So there are 4 possibilities. And I will figure it out in a moment which one it is. This is what we call a vertical asymptote. So x equals 2 is a VA. And I'm going to write what a VA means. A rational function has a VA, a vertical asymptote, at a value of x where it is, thank you, to be exact, I have to write something in parentheses. I'll show you an example. In parentheses, I have to write, assuming that in my case, in our case, x minus 2 as a factor does not cancel with an x minus 2 from the top. So let me give you an example right here, right now. So if I have x minus 2 and x plus 4 over x minus 2 and x minus 3, and this is our function, it's not, but I'm just giving an example. What is the domain of this function? Obviously not 2 and not 3. So after I write not 2 and not 3, I am allowed to simplify this. See, this factor does not stay in the simplified form. This factor will be a hole in the graph at 2, not a vertical asymptote. This factor still stays, and it will not be canceled with an x minus 3 from the top. The only vertical asymptote for this graph will be x equals 3. This will be a hole in the graph. So, to be exact, a rational function has a VA, vertical asymptote, at a value of x where it is undefined, assuming that that factor does not cancel with a similar factor from the top. I have to add that in because it's not correct. A rational function, when it's undefined, it doesn't necessarily have a vertical asymptote. It has a vertical asymptote if the factor still stays. Does x minus 2 disappear with a factor of x minus 2 from the top? No. Therefore, x equals 2 is a VA, vertical asymptote. Now, I also have to mention here, when a rational function has a VA, the behavior of this function left and right of the VA is what? The behavior of the function left, right of the VA. Remember what I showed. One option. Second option. Third option. Fourth option. What am I showing you? Infinities. Plus or minus infinity. This is mandatory. If it does not go to plus or minus infinity, it's not a VA. So they go together. If I establish that x equals 2 is a vertical asymptote, I know left and right must be infinities. What I don't know is the sign of those infinities yet. Here's how I check the sign. And I will put the sign in a minute. I'm going to use two numbers that I don't need in the chart. They will not be here. I'm not going to plot them. But something very close to 2 from the left and very close to 2 from the right, just to establish the sign. These will not be plotted. So plug in 1.9 at the top. I only need the sign. Don't calculate anything. Just tell me the sign. When I plug in 1.9. When I plug in 1.9. What is the sign when I divide a positive by a negative? I plug in 2.1, the top. I plug in 2.1. So positive of a positive, what is the sign? 2.1 minus 2 is a positive number. So we are done in one step with these two. I established that there is a vertical asymptote, and I established the behavior of the function near the vertical asymptote. It is negative infinity on the left-hand side of the asymptote and positive infinity on the right-hand side of the asymptote. Ready? Yes, I'm sorry. So when a rational function has a VA, the behavior of the function left and right of the VA must be plus or minus infinity. I don't know which one. I have to check. Okay. We are here now. This is clear. I cannot determine it unless it's something easy. I cannot determine it without the graphing calculator. Symmetry. If a function, a rational function, has a vertical asymptote at 2, it cannot be symmetric with respect to the y-axis. It cannot be symmetric with respect to the origin. There's no way, right? So the last two things that I need to determine are these two, and they go together. Now, assuming, here's a question for you. I have $1, and I want to divide it by, how many people are we now? 7 billion or 8 billion? 7 billion? Okay. So let's say for now I'm only thinking of this many. And let's say I start where the biggest population is, like China, India, and I finally get to you. So I give a little piece from my dollar to everybody, and I started, as I said, in China and India, and I finally get to your door. And I knock on David's door. How much will I have left from my dollar by the time I get to you? No, exactly nothing. So this, I cannot say equals 0, but it's approaching 0. Agreed? Okay, stay with me with that thought. Because of course I'm looking for the end behavior here. So here's our function one more time, x plus 1 over x minus 2. And you already observed that same degree over same degree. What is the degree of the top? 1. I want to factor it out. What is the degree of the bottom? I want to factor it out. How many terms are left inside? Is it possible? If I start with 2 terms and I factor something out, I have to have 2 terms. If I start with 10 terms, I factor out something, I have to end up with 10 terms. So, because if I only write 1, x times whatever, I'm not going to get 2 terms. Right? Okay. X times what is x? Awesome. X, I have to write plus. X multiplied by what is 1? X times 1 is not 1. Exactly, it's the multiplicative inverse, of course. Right? So 1 plus 1 over x. Let's check. X times 1 is x. X over 1 times 1 over x is 1. Agreed? Perfect. So please tell me what you have in the denominator. Yes? Yes? Awesome. So I'm simplifying this x with this x and write 1 and 1. And now my purpose is to find out what happens here, the end behavior, like we know from polynomials. I need the end behavior here when x approaches positive infinity and when x approaches negative infinity. Good. So keep this in mind. So tell me, where does this go as x approaches infinity or negative infinity? Doesn't matter. Where will this go? 1 over x when x approaches infinity. Where will this go? Right. Where does this go? 1 over x when x approaches infinity or negative infinity. What will this approach? You already told me. With a number. Yes. So this will approach 0. Where will 2? Now I have $2 divided by 7 billion. Where will this go? Right. So where will this whole thing go when x approaches infinity? The entire function, what will the entire function approach? Look at what is left. You can say 0. Look at what is left. This is gone, 1, 1. This is 0. This is 0. What is left? 1. This is the end behavior. This is the end behavior and the horizontal asymptote. So 1, 1, y equals 1, horizontal asymptote. And let's talk about that. What is the meaning of a horizontal asymptote? Okay, so let's write it. When x increases to infinity, and I'm going to write in parentheses, or decreases to negative infinity, a rational function, and the rational approaches a number, not infinity, a number, comma, that number is the horizontal asymptote and the function's end behavior. Let me read this back to you slowly. When x increases to positive infinity or decreases to negative infinity, and the rational function approaches a number, that number is the horizontal asymptote, and the functions and behavior as well. We showed, and I'll show you the shortcut in a minute. We showed that this function, after some algebraic manipulations, we showed that when x approaches infinity, this whole number, this whole function approaches 1. Therefore, 1 is the horizontal asymptote and the end behavior. Is there a shortcut for this? Yes. As long as we have the same degree of a same degree, the horizontal asymptote is the leading coefficient over the leading coefficient. What is the leading coefficient of the top? What is the leading coefficient of the bottom? How much is 1 over 1? 1. And this completes our table. Let's graph it. I only need my chart. Everything else is useless now. When we graph a function with asymptotes, what do you think we have to graph first? The asymptotes, mandatory. I can't start before I graph the asymptotes. You told me x equals 2. Perfect. It's not part of the graph. They are not part of the graph, but they have to be graphed. And then you said y equals 1. Perfectly. My next step is to plot 2 ordered pairs. Can anyone dictate the first ordered pair I have to plot? Very good, awesome. Can anyone give us the second ordered pair I need to plot?
0, 1.
So follow my marker, please. From approaching 1, the function crosses at -1, 0, crosses at 0, -1/2, and approaches negative infinity on the left-hand side of the vertical asymptote. One more time. From approaching 1, crossing at -1, 0, crossing the y-axis at 0, -1/2, and approaching negative infinity on the left-hand side. It can never cross this line. On the other side, coming from positive infinity, coming down to approach 1. That's the rational function. Can anyone give us the range of this function? Careful. I lifted. So one more time the range. Very good. That's it. These are not friendly functions. They're not. They have a lot of ins and outs. Things like asymptotes, behavior near the asymptotes, and behavior with the asymptotes, range that is what it is. Okay, so let's look in the book and choose another type 1. Any that you want. Again, I accept any method, but without a table, without a study, it's going to be very difficult. So if you want to go through all these pages, please do. I accept, as I said, any method. I don't recommend this. I don't recommend it because it's not summarized anywhere. You have all the information on 2 pages. You don't know where to start. So if you don't like this chart, invent your own. I will not assume responsibility or take credit for this. I was taught this way. I wish I had invented it, but I didn't. So all the information has to be summarized, because after putting all the information on 4 pages, you will not know where to start. I'm not saying that I have something against this method. I'm just saying it's not summarized. I will not be able to look in 5 different places and graph my function. I will not. Okay? So I don't recommend this. So, but it's up to you. I will accept it. Okay, on page 427, please choose between 21 and 88. But I need type 1. So please make sure you choose type 1.